And here we go, our last lesson, 5.5, before your unit test. It's all about absolute value. Our objective today is that students will be able to solve and graph absolute functions and inequalities. So really quick, let's recap. As we all know, there are four symbols for inequalities. What are they? The first one is my less than. Second is my greater than. Then we have less than or equal to, less than or equal to. Then I have my greater than or equal to. Greater than or equal to. How do I know to read this? So one really trick that I learned back in how many years ago is that it's like a Pac-Man. If I have a variable and it's open to the variable, it means greater than. If it is facing away from the variable, then it's less than. So this would be greater than because it's opening to the variable, and since it's facing away, opening from the number, it's facing away from the variable, this is less than. It kind of formed that LESS kind of thing, maybe. Alrighty, how do you graph the inequalities? Many of us should remember from Algebra 1, whenever you're doing less than or equal to, you use an open circle. And when you're having that equal sign at the bottom, you use a closed or a shaded circle, as some of you would call it. Now the first one says, let's just graph really quick. X is greater than negative 3. So at negative 3 is going to be an open circle. Anything greater than goes to the right. So greater than means we're going to go to the right. Here I have, and I always read from the variable, x is greater than or equal to 1. Greater than or equal to is going to be a closed circle at 1, and it's greater than, again, it goes to the right. If you had something like less than, then your arrow will be going to the left. Now, some points to remember. When you're solving inequalities, when you're dividing by a negative number, we have to flip the inequality sign. So if it was a less than, it will now become a greater than. Absolute value, when we're doing this, can never be negative. We know that we can't find a negative. We can't get an absolute value from a negative. So absolute value will always be a positive. So now this is where it gets into our lesson. We have two important things we need to remember. When we're solving an equation which is with an equal sign, there will always be two solutions. Absolute value, most of the time there are two solutions. So it will be everything that's in my absolute value has to be equal to C, or everything that's in my absolute value can be equal to negative C. Because if I take the absolute value of negative number, it will be a positive. Now it's very similar for an inequality. There are also two answers, which is the first one is everything that's in my absolute value can be greater than C, or everything that's in my absolute value, again, I'm going to make this negative C, but what's special with inequality, when I make the number negative, I switch my inequality sign. And again, this should be negative C, it's not connected. So, these are my two important formula. You have to get everything within that absolute value sign. Any excess, we need to get rid of that first, okay? So let's look at some examples. We're going to start with our basics. So how would we solve this simple two-step equation? We would minus 1 on both sides. 2x is equal to 8. Then I will divide by 2 on both sides. X would be equal to 4. That's just a regular equation. What about if I have something like this? So let's work on this. Remember, I said everything has to be by the in the absolute value, so I need to get rid of anything excess. So minus 1 on both sides. This will give me 2 absolute value of x plus 5 is equal to 8. This is multiplication, so I want to divide both sides by 2. I'm left with the absolute value of x plus 5 is equal to 4. And now remember what I said, this has two answer choice. It can be x plus 5 is equal to 4, or x plus 5 is equal to negative 4. And then all I'm going to do is go ahead and solve these. Minus 5 on both sides. X can be equal to negative 1. Here I will minus 5 again on both sides. X can be equal to negative 9. So these are my two answer choice. X can be negative 1 or X can be minus 9. You have to remember to get rid of anything that's by my absolute value sign. Now let's look at a simple inequality. Here I will again minus 1 on both sides. Cancel. 2x is less than or equal to 8. Divide by 2. X is less than or equal to 4. Now how would we graph that? At x is less than or equal to 4, that's going to be a closed circle. Less than or equal to means I'm going to my, oops, that doesn't look right. It means I'm going to draw my line to the left because it's less than anything that's less than. So I want to draw all of this to the left. Now let's take a look at one with absolute value. We're going to somewhat do the similar thing, get only the absolute value by itself. Minus 1 on both sides first. 2 absolute value of x plus 5 is less than or equal to 8. Then I want to divide by 2. Remember, get rid of my plus first. Anything, because this is multiplication, that's the last thing I'll get rid of. This becomes x plus 5 is less than or equal to 4. Now, just like we did up here, there are two answer choices. Here, I am going to write my answer choices. Now, look back at our formula. We said that one answer choice will be x plus 5 is less than or equal to 4. And the other choice will be x plus 5 is greater than or equal to negative 4. And I'm going to go ahead and solve these. When I solve these, minus 5 on both sides, I have x is less than or equal to negative 1. One answer choice here. Then I have minus 5. I am going to minus the 5 on both sides. That's cancel. X is greater than or equal to negative 9. Let's see, how would we graph that? So x is less than or equal to negative 1, which is right here. Anything less than would be to the left. And then x is greater than or equal to negative 9. It's going to be a whole circle, and it's going to be greater than. So all my answer solution would be between these two circles. The very important thing is, how do we switch these up into two answer choice? Number 1, more examples. Oh, I'm thinking, oh, we're all the way at the bottom here. Nope. Okay, so the first thing I want to do is get rid of this 4. Why not the 3? Because this is multiplying. That's attached to my absolute value. So that's the last thing I want to get rid of. This is a positive 4, so I minus 4 on both sides. This is canceled. Minus 3, absolute value of x plus 1 is less than or equal to negative 21. Now I get rid of my minus 3. Remember, divide by a negative number means I switch my inequality side. So instead of less than, now will be the opposite. Less than, greater than or equal to 7. Then I have two choices. I have x plus 1 is greater than or equal to 7, or x plus 1 is less than or equal to negative 7. Remember, we switched the signs because when I divide by a negative number, I have to switch the inequality sign. And then here I just go ahead and solve this as I would as a normal inequality. Minus 1 on both sides, that's cancel. X is greater than or equal to 6. And then here I would minus 1 again on both sides. X is less than or equal to negative 8. And these are my two answer choices. Remember, with absolute value, you will always have two answer choices. Now here, absolute value of x minus 3 divided by 2 is less than 4. Again, get my absolute value by itself, so I want to get rid of my denominator. This I will go into times 2 on both sides, and I'm left with absolute value of x minus 3 is less than 8. Now I don't even need to do anything else because I have everything in my absolute value on one side. Break these up. X minus 3 is less than 8, or x minus 3 is greater than negative 8. And then what I want to do is just go ahead and solve. Add 3 on both sides. X is less than 8 into 10, 11. That's one of my answer. And then here I would add 3 on both sides. X is greater than negative 5. We're not graphing these examples, we're just doing them algebraically. Now, let's take a look at number 3, which is right here. Now, this is everything is already in the absolute value sign. I don't need to move anything over. So let's just start by branching these off. I have 3s minus 15 is less than 30, or what's my other option that I have for this? 3s minus 15 is greater than negative 30. And then all I want to do is solve this. Add 15 on both sides. I'm left with 3s is less than 45. Divide by 3 because I want s by itself. S is less than 15. 15, 3 is 45. That's one of my answer choice. Now let's see what's my other. Add 15 on both sides. 3s is greater than negative 15. Divide by 3 on both sides. S is greater than negative 5. Bam, that's my second answer. Now, number 4 is a combination of a lot of things here. Let's see what's going on. Again, get rid of my 4. I don't need that 4. Absolute value of 2 over 5 and minus 8, we all hate fractions, is greater than or equal to 8. Now that I have this, two answer choice, what are they? 2 over 5 and minus 8 is greater than or equal to 8. Then I have 2 over 5 and minus 8 is less than or equal to negative 8. How do I go ahead and solve this? Now get rid of my 8. Add 8 on both sides. This is cancel. 2 over 5n is greater than or equal to 16. I think we need some more space here. Now, this is all this is when we switch these down. I'm just getting some space. Like solving a regular equation. Now I need to get rid of the 5, so I'm going to times 5 by on both sides. These are canceled. I'm left with 2n is greater than or equal to 6, 5 is 30, 5 and 3 is 80. Now what I did was to get rid of that denominator. Get rid of that denominator means I am going to have a beautiful 2n is greater than or equal to 80. And then, since I want n by itself, I'll divide by 2 on both sides. N would be greater than or equal to 40, and that's one of my answer choice. What about my second answer choice? Let's see what's going on here. Add 8 on both sides. this is cancel, and I'm left with 2 over 5. N is less than or equal to 0 times 5 on both sides. This is canceled. 2n is less than or equal to 0. Divide by 2 on both sides. 0 divided by 2 is 0. It's not undefined. So my second answer will be n is less than or equal to 0. Okay? So there we go. Now the last thing I want you to write is just look at this. We haven't been graphing anything, but I just want to take a look at these two examples. How do I write an inequality for this? So this can be, what is this number right here? If you look at this, they're in increments of 2. So this would actually be a negative 10. And this will be 14. So x is less than or equal to negative 10, or x is greater than 14. Remember, this is an open circle, which tells me I'm going to use a greater than because it's pointing to the right, and here I'm using less than, it's going to the left. Now here, let's look at something like this. This says that x is between these two numbers. So since x is between these two numbers, I know x will be in the middle. So x, before we even do that, let's write these out. So we know x has to be going to the right, so x is going to be greater than negative 7, and x is going to be less than or equal to 6. So now I have these two. I can then, because we're taking Algebra 2, our third year of math, I can write this as x is less than or equal to 6, or x is greater than negative 7. And this is my final answer. You might now lose points for this, but because this is our third year of math, we can write it this way. Just break them down. Open circle means I use this, closed circle means I use that, and I just combine them. Alright, that's it for our final lesson of Unit 5, Radicals and Absolute Value. Now go ahead, remember, as I always like to say, practice makes perfect. See ya!